thank you for watching this video. So in this video, we're doing question 7 of May, June 2024 question paper mathematics paper 1. The topic is the financial mathematics. So let's go. 7.1. 6 years ago, Tabo bought a phone for 13,000 rands. The value of the phone depreciated annually according to the reducing balance method. The value of the phone now is 8,337 rand 75 cents. Calculate the annual rate of depreciation. Let's read this thing again. 6 years ago, Tabo bought a phone for 13,000 rands. The value of the phone depreciated annually according to the reducing balance method. The value of the phone now is 8,337 rand 75 cents. Calculate the annual rate of depreciation. So what are they saying? They say at 7.1, right? We have a friend. We have this friend here. His name is Tabo. We have a friend with the name Tabo. So Tabo bought a phone, right? He bought a phone. For how much? He bought this phone for 13,000, right? And we are told that 6 years later, the value of the phone is what? Is 8,337 rands 75 cents. That's what they're telling us. So we have a friend, Tabo. So Tabo bought a phone for 13,000 rands. And then 6 years later, the value of the phone have depreciated to that. So which means the value of the phone went down to that amount. So today, the value of the phone is this one here, which is 8,237 rand 75 cents. So what are they looking for us? They want us to find the annual rate of depreciation. So which means how much, at what rate was it losing value per year over that 6-year period? That's what they are looking for. So what do? They told us so the phone that he bought for 13,000 depreciated over 6 years, which means it lost value over 6 years. But they want us to find how much was it losing value at per year. What was the rate of value loss per year? Which is the interest there, not the interest, the rate of depreciation I. Fine. So if your phone or your asset is depreciating, you can depreciate at a reducing balance. Reducing balance method. So which means if your asset is depreciating at a reducing balance method, it's depreciating at this formula here. A is equal to 1 minus I all raised n. Right? I'll explain the A's and P's shortly. Or you can depreciate at a straight line. Straight line method. So your phone can depreciate at reducing balance method or straight line method. And if it's depreciating at a straight line method, here's the formula for your straight line method. So in our case, we are told that our phone is depreciating at a reducing balance method. So this is our formula that we're going to use. Let me write it down. So it's A is equal to P into 1 minus I all raised n. That's what we have. So now let's go down. What is A? A is the book value. You are asking yourself, what is a book value? A book value is the value of an asset after it has depreciated. Or you can say, it's the book value of an asset after depreciation has been taken into account or has been considered. That's what a book value is. For example, this phone was bought at 13,000 and it depreciated over 6 years at this rate here. And today it's 8,337 rand 75 cents. So of course, it's clear that from 13,000 to 8,337 rand 75 cents, the cell phone have lost value. The phone have lost value, right? So this amount is the value of this phone after it has depreciated for a certain period at a certain rate. So this amount here is called the book value. This amount here is called what? The book value. This is the book value of an asset. It's the value of an asset after it has depreciated. It was initially 13,000 and today is 8,000. So it has depreciated. So that is the book value of it. So in this case, we say A is the book value. It's the book value A. And P is your what? Is your purchase price P. How much did you purchase this item for? He purchased it for 13,000. So this is the purchase price. And I is the rate of depreciation. So what is the I is the percentage of depreciation or the rate of depreciation, and N is the number of years through which this cell phone was depreciating at, which is 6,000 in our case. So in our case, we say, okay, A is equal to P into 1 minus I all raised N. This is the formula for the reducing balance method. So we're told that Tabon's phone was depreciating. It is the reducing balance method, right? Fine. So this is our formula that we're going to use. So I said A is the book value of the phone. What is the book value? It's the value of the phone or asset after it has depreciated. So in this case, it's going to be 8,337 rand 75 cents. Right? P. What is your P? I said P is your purchase price. How much was this phone purchased for? So the phone was purchased at 13,000 rands. Fine. What else do we have? We have I. What is I? I is the rate of depreciation, which is what we're trying to find. Because they're saying, calculate the annual rate of depreciation. So, we're trying to find I. What is I? That's what we're trying to find. Then we move on. Then N is the number of years. So we can see that the value of the phone today is 8,237 rand 75 cents. How long did it take for a phone to get to this point? It took 6 years. So it's the number of years to which the item has been subject to depreciation. Or is the period over which the item has depreciated on. And that period is 6 years. So N is equal to 6. Then you substitute all these things on your formula. So your A is 8,337 rand 75 cents is equal to your P, which is your purchase price, which is 13,000, right? Into 1 minus I all raised 6. So what we're looking for I. So what we're looking for I. What do we do? Divide by 13,000. Divide by 13,000, both sides. Because we're trying to get to this I, but this I is protected by this and is protected by that. So get rid of everything that is protecting your I so that you can face your I and find its value by force. So let's go. So this and this go away. So find the answer to this. Use a calculator. What do you say? Say 8,237 rand 75 cents all divided by 13,000. What do you get? We get that the answer to this is 0.6414 maybe. Is equal to, what is the answer to that? This and that go away, you're left with 1 minus I all raised 6. That's what you're left with. Right? Fine. Let me write this. You're left with 1 minus I all raised 6. So what do you want to do? You want to find I. So you need to get rid of that so that you can have access to I. What do? You take the 6th root, both sides. So this and that go away. This side you're left with 1 minus I. And on the left hand side, take the 6th root of that. If you take the sixth root, you will find that this is equal to the answer to this equal to 0.9286. That's what we're left with. Then you solve for I. Now you have direct access to I. Transpose this to the side. So what you have 0.9286 minus 1 is equal to negative I. So let's go and find an answer to this. What do you say? You say this minus 1. So you get negative 0.071135 is equal to negative I. But you're looking for the rate, so divide by minus 1, divide by minus 1. Right? No problem. So you find that 0.07135 is equal to I. But you want the rate of depreciation. So you multiply this by 100. Therefore, your rate is equal to this times 100. 0.07135 times 100. Therefore, your R is equal to the answer to that. Divide by negative times 100. So it's equal to 7.14%. That's what you get. So the rate of depreciation is 7.1% per annum. Because you were told that this phone was depreciating annually, which means it was depreciating at a percentage of 7.14 per annum. And you are done with 7.1. And I hope it does make sense to you as it does to me. So I'll clean this board now and we'll go to 7.2. Okay, so now we're doing 7.2. 7.2 read as follows. They are saying Eric and Tandy need to save 80,000 each to go on a holiday at the end of December 2027. Let me read this thing again. Eric and Tandy need to save 80,000 each to go on a holiday at the end of December 2027. Fine. So, what they're saying, we have Eric, right? And we have Tandy here. So, Eric needs 80,000 in December 2027, right? And we have Tandy here. Even Tandy needs her own 80,000 here. So with Tandy, now Tandy needs her own 80,000. When does she need it? She also needs it at the end of December 2027. So these two people, Eric and Tandy, want to go on a trip. So Eric will need 80,000 to go to this trip at the end of December 2027. And Tandy will also need 80,000 to go on this trip at the end of 2027. So I'll say they are going to the same trip, which requires that amount of 80,000. Or maybe you need a minimum of 80,000 to be qualified to go to that trip. Let's say that for now. Fine. So they are saying now, Tandy decides that she will start saving at the end of January 2025. She will make 36 monthly deposits into a savings account that pays 8.6% per annum compounded monthly. The deposit will be made at the end of each month. So what are they saying? So now they're talking about Tandy. Now let's tell us about Tandy. So here's Tandy. So they're saying Tandy will start saving at the end of January. So let me make a timeline here. So here's Tandy here. This is Tandy's timeline, right? This is Tandy's timeline. So she will start saving at the end of January. So I'll say this is the beginning of January. Here is the end of January. The month starts here. Here is the end of January. So this point here, this is end. This is end. Jan 2025. This is when Tandy starts. Tandy starting here to save. And she wants to make a total of 36 monthly deposits. Right? So she will save for a period of about 3 years. Because if it's 36 payments made monthly, that is 3 years. So here's that. Let's look at what is happening. So Tati will start here, and in total she will make 36 payments. Because look, the first payment was made on the first month, but at the end of the first month. Because this is when the first month starts, January. This is the end of January. So the last payment should be made at the end of December, which is 3 years later, which is 36 months later. Because what we have here, because we know that the trip that they want to go to it at the end of December. So look, Tandy starts here by making the first deposit. Then, end of December the same year, which is on the 12th deposit. The 12th deposit will be at the end of December 2027. This is where the 12th deposit will be sitting. And then the 13th deposit may be here. When will this deposit be made? This 13th deposit here, sitting at this point, will be made in January. Oh, sorry, this can be 2025. Should be end of December 2025, not 2027. So, now the 13th deposit will be made in January and Jan 2026. And that year, which is 2026, she will also make 12 deposits, which means at the end of December that year, she will be making what? She will be making her 24th deposit at the end of that year. So the 21st payment will be made at the end of December 2026. Right? Look, the 25th payment will be made here. What is this? This is end January, which is the next year. Here, this is end January 2027. Here. And that year should also make another 12 payments to make them 36, to get to 36. And this 36th payment is made in end December 2027, when the trip is due. So this is Tandy's timeline. Let me repeat it. So Tandy needs 80,000 at the end of December 2027. Right? No problem. Then what they're saying now, they're saying she starts saving at the end of January 2025. And she's going to make 36 payments monthly into that account, into that savings account. So she's going to make a total of 36 payments monthly. She's going to make a total of 36 payments. And each payment will be made monthly. Which means she will make payments over a period of 36 months. So here is it. These are where her payments are made. So the first payment is made at the first month, right? And that year, 2025, first month of January 2025, the payments that she makes in January 2025 will be his first payment. And in 2025 in total, she will make a total of 12 payments, because we have 12 months a year. So from January 2025 to here, she will make a total of 12 payments. That's why I have 12 there. And then now, on the other year, end of January 2026, she will be making a 13th payment. And that year as well, she will be making what? She will be making a total of 12 payments, because this is a year. So each month, she's making a payment. Look here as well. at the end of December 2026, that is the end of the second year since she started saving, she will have made 24 deposits at the end of 2 years. Look now, she's getting to the third year. The 25th payment will be made on the end of January 2027, right? And that year should also make 12 payments, which will add up to 36. So, on the first year, here's the first year. First, it starts here to here. She made a total of 12 payments, right? Then, when this one ends, the new year starts, because this is end of January, so your early January is somewhere here. So, the new year starts here, and it ends there. She made 12 payments here as well. Another year, new year 2027 starts here, and ends there. She made 12 payments there as well. So in total, she made 36 payments. 12 payments, 12 payments, 12 payments. It all adds up to 36 payments that she wants to make into her account. So the last payment will be made exactly on the month she's supposed to go to this trip. That's what they're telling us. And what else they're telling us, they're saying now, our friend made a number of payments, is there's 36 of them. They're also telling that the interest rate is what? The rate of that she's earning into that account is 8.6% per annum, which means a year in total, each year should be getting 0.86%, right? But now that 0.86% will be divided over the 12 months, which means if you're saying now she's getting she's getting okay, let me say, just say she's getting 8.6%, right? Per annum. Per annum means per year. Annum is a year. The interest rate that she's earning is what? Is 8.6% per annum, which means she's getting 8.6% a year. You know that she's earning this interest monthly. She'll be earning interest monthly. Not this one, but she'll be gaining interest monthly because her account earns interest monthly. So now, in a year, you have what? You have 12 months. You have 1 up to 12 months. So this 8.6% of yours should be divided among that 12 months. So when you add up all of those, so that once you divide this 8.6% by 12 months, you will be knowing how much does that account earns interest per month, because you know that that 12% is distributed over the 12 months of a year. So what do you say? Her interest now, it should be 0.086, which is, this is 8%, is it 8.6%, same as that, divided by 12. So her interest rate is 0.086% divided by 12. So which means that 8.6%, you spread it out the entire year so that you know how much does each month, how much interest do you gain per month, if that makes sense. So here's the situation. So this is Tani's situation. She started saving at the end of January 2025 by making 36 payments. And her last one will be at the end of December, right? No problem. She will make a total of 36 payments, and the interest, this is the monthly interest rate here. Because a year we know is this one, 8.6%, but a month should be this one here, which is this 8.6% divided by 12. Then you will know how much she's getting monthly. And we're done with Tani's situation. So let's move on to Eric. We'll move on to Eric. Okay, so now we'll move on to our friend Eric. They are saying Eric calculates that if he makes 48 deposits of 1,402.31 cents starting at the end of January 2024, he will have enough money to go on a holiday. He will make his deposits into a savings account at the end of each month. The savings account pays interest of 8.6% per annum compounded monthly. No problem. Let me read this thing again. They're saying Eric calculates that if he makes 48 deposits of 1,402.31 231 starting at the end of January 2024. He will have enough money to go on a holiday. He will make his deposit into a savings account at the end of each month. The savings account pays interest of 8.6% per annum compounded monthly. So we have a second friend, Eric. Here is Eric. You can see that Tan started saving at the end of January 2025, right? Eric started a year earlier. Eric started at the end of January 2024. And he will make a total of 48 payments. And each payment is made monthly, which means those payments will be made over a period of 48 months. And that 48 months is what? That 48 months is 4 years. So this 36 months for Tandy was 3 years. And their accounts are both earning the same interest rate. But this one started a year later and this one started a year early compared to that one. So now this is the beginning of January 2024. Then Eric started making his first deposit here, right? When is this? This is what? This is end January 2024. This one, right? No problem. And then his draft deposit will be made. His draft deposit, will be made at the end of December 2024. His 30th deposit will be made when? At the end of Jan 2025. So when Tandy will be making her first deposit, Eric will be making his 30th deposit. So his 24th deposit will be made at the end of December 2025. His 25th deposit will be made when? At the end of Jan 2026. Now, at the end of this year, this is the end of the third year, so he'll be making his 36th deposit, right? At the end of 2026, which is this will end December 2026. And then his 37th payment or deposit will be made at the end of January. This is a new year, 2027. And then his 48th deposit will be made at the end of December 2027, during the time of the trip. So our friend, her account is getting interest of 8.6% per annum, right? So over 12 months, each month he'll be getting this interest rate, because you get 8.6 for the year, and you know in a year there's 12 months, so distribute that 8.6 over 12 months. This is what you would get, right? No problem. Then we're also told that our friend is paying how much? He's paying 1,402 rand 31 cents. This is the amount that our friend is paying monthly into that account. And he will make a total of what? Of 48 payments. That is Eric. No problem. What are they saying now? They are saying now, calculate the difference between the total that Eric and Tandy will deposit in their respective savings account over the given period. So they're saying at the end, what will be the difference between their deposits into those accounts? Which means how much will Tandy deposit into her account and how much will Eric deposit into her account? Then find the difference between them, because they want to see what will be the difference into those accounts, what will be the difference in the deposited amounts into those accounts. That's what they're asking. Fine. How do we do that? We know Eric was paying 1,402 cents a month, and he paid that amount over 48 months. So he paid 48 times of this amount. So we can find how much he deposited into his account. So we can say Eric's account he was depositing how much? He was depositing 1,402 rand 31 cent. And there's how much of them? There's 48 of them. So he was depositing 1,402 rand 31 cents for 48 months. So the answer to this will tell us how much did Eric deposit into his account. Right? Let's do that. So the total is, let's do that. Say 1,402 rand 31 cents times 48. We get that Eric deposited a total of what? A total of 67,310 rands 88 cents. So this is the total that Eric deposited into his account. He deposited this much after 48 payments. Fine. Now what we need to do this for Tandi and see how much did she deposit into her account. And then once we know her total, we can find the difference between the two. Because what they want us to find, they say calculate the difference between the total that Eric and Tandi paid. Calculate the difference between the total amount that Eric and Tandi will deposit into their respective savings account over the given period. So they want us to find the difference between Eric's total and Tandi's total. So what we need to do the same calculation for Tandi and then find the difference. But the problem now is that for Tandi, we don't know how much she was paying per month. So what we need to find, we need to go back and find how much was Tandi paying each month. If we can find how much Tandi was depositing each month, then we can do the same calculation. So let's go and do that. So we said her first payment was made at the end of January 2025, right? And the last payment was made at the end of December 2027, at the moment when the money was needed. Because the last payment, which is the 36th payment that she made it at the end of December 2027, when she needed to go to the trip. So that money was deposited and the entire 80,000 was full, and then she was eligible to go to the trip and she was qualifying to go to the trip. So this last payment of whatever deposit she was making did not stay into that account, this one. You can say that the first one, right, was deposited. The first deposit was made at the end of January. So from 0 up to the 36th month, but it was made at the end of January. So if the first deposit Tandi made was the end of January, it stayed into that account for the remaining 35 months. It can't be 36 because the 36th month it should be January, but January there was no money for all of January until the end of January. So her first deposit stayed the remaining period, which was 36 months, right? So the last one that she made here didn't stay for any time into that account. It was just deposited, 80,000 was complete, and the money was taken out for the trip. That's what happened, because she needed that money at the end of December. So when she deposited her last amount, the money was immediately available. The 80,000 was complete for her to go into the house. I hope it does make sense. So what do? You say, okay, we know that the future value should be 8,000. So we want her monthly deposits into that savings account, right? That's what we're looking for. All divided by I. So what is F? F is the future value of the investment. So she wants her investment to be what? She wants her investment to be 80,000 at the end of when it's all said and done. Then that X are those monthly deposits. How much is she putting into that account? It's what you don't know. I is the interest rate earned into that account. We're told that she was earning what? 8% per annum, 8.6% per annum, which is each month she will be getting this here, which means 0.086 over 12. Each month, this is what she'll be getting. Fine. Then N is the number of payments. Tandi made a payment of 36 payments into that account. And that's it. So we can substitute this here. Future value 80,000. Monthly deposits, what we don't know, which is what we want to find. Once we find the monthly deposits, we can multiply it by 48 and see how much did she deposit into the account. So let's do that. Future value, how much? I said it's 80,000. She wants to have 80,000. The future value of this investment should be 80,000. It's equal to, this is the monthly deposit into the account, into 1 plus 0.086 over 12 raised to 36 minus 1, all divided by 0.086 divided by 12. Right? So we want the value of x. Cross multiply. So it will be 8, this times that, 80,000 times 0.086 over 12 is equal to what? X into 1 plus 0.086 over 12 raised to 6 minus 1. What are we looking for? We're looking for x, right? So we can divide by this thing here. Divide by this, which is 1 plus 0.086 over 12 raised to 6 minus 1. Divide both sides, which means we have 1 plus 0.086 over 12 raised to 6 minus 1. So this and that go away. So your x is equal to. Then punch the answer to this. The answer that you will be getting, which will be the monthly deposits into that account. You'll know how much time was depositing monthly into that account. So let's do that. We say 80,000 times 0.086 over 12 divided by 1 plus 0.086 all over 12, all is 36 minus 1. You get that? Tandy was paying how much? 1,955 rands 78 cents. So this is how much was Tandy paying into that account. It didn't make sense that she's paying more than Eric, because you see Eric was paying 1,400 and Tandy was paying more. If you look at them, they both, their accounts are both earning the same interest rate, because you see Eric was getting 8% per annum and Tandy was also getting 8.6% per annum. So they are getting the same rate. 8.6% per annum, 8.6% per annum. Fine. But Eric is saving over a longer period of time, and Tandy is saving over a shorter period of time. So the longer the period of investment, the lower will be your required deposits in order to meet your financial goals. So Tandy had a shorter period to reach the same goal, which means her period was 12 months shorter, which is a year shorter than that of Eric's. So Eric will have to will pay a lower amount to reach the same goal if their accounts are earning the same interest rate. So now we know how much Tandy was paying per month. So we can find how much did she deposit into her account in total. So let's go and do that. So you can say, okay, you can say Tandy's account deposits, right? So this is the total, right? So these are deposits as well. So they should be equal to what? It should be, she was depositing 1,955 rand 78 cents for how long? For 36 months. So how much did she deposit into that account in total? The answer to this will be the total amount that she deposited into that account. So 1,955 rand 78 cents times 36. So the amount that she deposited is what? 70,408 rand 8 cents. So this is the amount that Tandy deposited into her account. She deposited this much and Eric deposited this much in total. So Tandy deposited more than Eric. So if you want to find the difference, it should be Tandy's, it should be Eric's total, or Tandy's total, the big one. Tandy's total, right? Minus Eric's total. Then you find the difference. So the difference is equal to Tandy's total, which is 70,408 rand 8 cents, minus what? This should be 0. Minus Eric's total, which is what? 67,310 rand, 88 cents. Therefore, the difference between their amounts should be the answer to that. So minus 67,310 rand, 88 cents. So the difference between the amounts they paid is 3,097 rand 20 cents. So what does that mean? It means that our friend Tandy paid 3,097 rand 20 cents more than Eric did to meet the same goal over a period of 36 months, while Eric take a year longer to save the same amount but at a lower at a longer period with a lower required deposit. So this is the difference between their totals, and I hope it does make sense to you as it does to me. So I'll clean the board and we'll go to the next question. Okay, so now we're doing 7.3. So let's go. They are saying Leslie was granted a loan of 225,000. The rate of interest on the loan is 9% per annum compounded monthly. Leslie will make monthly deposit of 5,500 starting exactly 4 months after the loan was granted. How many payments will Leslie make to settle the loan? No problem. So what do we have here? Here we have a friend, Leslie, right? And Leslie took a loan, right? Of how much? Of 225,000. This is the amount of a loan that our friend Leslie took. So, as she was taking this loan, the interest on the loan is what? It's 9%, right? Per annum. Compounded monthly. So what does this mean? Which means over a year, our friend Leslie will be charged a percentage of 9% on the loan. Right? So our friend Leslie will be charged a total of 9% on that loan per year. But that 9% will be charged over a period, it's charged over a year, right? But it will be divided over 12 months. That's what will happen. So our loan will be gaining interest monthly. That's what this thing means. So which means you need to know how much interest was gained or was charged on the loan each month. That's what you need to know. How do you get that? It's okay. It will be your 9% because 0.09 is 9% divided by 12. So 0.09 is 9%. So this 9% that is earned over a year, you are dividing it by 12 so that you can know what is the interest each year. That's what we are doing. That is what I'm doing. So which means, sorry, not which year, each month. So that 9% for the year, you divide it by 12 so that you know what is the interest each month. But all of those interests of yours will add up to 9% at the end of the year because you are charging 9% per annum. So the answer to this gives you the interest rate per month. This is the interest. This is the monthly interest rate, the answer to this thing here. So since our loan is gaining interest monthly, right? Our loan is gaining interest monthly. So our friend is expected to make those payments monthly. So when you take a loan, the first payment is expected at the end of the first investment period or the first compounding period. So if your loan is compounded quarterly, the first payment is expected a quarter from when you took the loan, right? If your loan is compounded monthly like we do here in this case, The first payment is expected a month from when you initially took the loan. But we're told here that this friend of ours will make his first payment 4 months later, which means he will have missed some payments in between that he should have paid, because he was supposed to start immediately a month after the loan was granted. So if he starts 4 months later, what does that mean? It means that our friend is somehow late, and whatever months that he was late on, he was charged interest those months for the outstanding balance. Right? So let's do that. So I'll draw a timeline here for Lacey. This is Lacey's timeline. So here's Lacey's situation. So this is the beginning of things, beginning of time when she was getting a loan. So they credited her for what? 225,000 rands. And then now, on the first month, Lacey didn't pay, because we're told that Lacey will make monthly deposit of 5,500 starting 4 months later. So she will start paying on the 4th month, which means on the first month she didn't pay, on the 2nd month she didn't pay, on the 3rd month she didn't pay, on the 4th month that's when she started paying what? 5,500 rands, the monthly amount that she's expected to pay. She started paying here. So she missed payments and started paying on the 4th month. The question is, how many payments did she miss? She was got the loan here, which is here. You can see it here. Then at the end of the first month, she missed a payment. This is payment number 1 that she missed. Here, this is payment number 2 that she missed. Here, this is payment number 3 that she missed. So our friend Lacey missed a total of 3 payments. So what are we going to do? Since she missed a payment, she was supposed to pay each month at the end of each month. But she missed payments for 3 months. So she's going to be charged interest for that 3 months. That's what we should be doing. Charge her interest for 3 months. Let's go and do that. We know this is a compounding interest. So we're going to use that to calculate how much is she owing at the end. Actually, at the end of 3 months. Let's go and find how much is she owing at the end of 3 months. Because she missed this payment, she missed this payment, and she missed this one as well. Then she started paying on the 4th month. So that's fine. We know her balance on the loan is 225,000 at the beginning of things. Let's go and find how much was the balance at the end of 3 months. Let's go and do that. So what do? Say A is equal to P into 1 plus I all raised n. That's what we do, right? So A is your accumulated amount after you have gained interest. P is the principal amount, which is the loan granted. And N is the duration, because we're trying to find what is the balance on the 3rd month. So here's what you need to know. I'll say, okay, I'll calculate in a funny way, but the same way. So A is equal to P, which is the amount that the amount that she took out for loan for, which is 225,000. Right? Times what? Which is 1 plus 0.09 over 12 raised 3. So the answer that you will get here is the balance here on the 3rd month. At the end of the 3rd month, the answer that you will get here, because I raised it by 3 because she missed a payment by 3. She missed 3 payments, which means she did not pay her loan for a period of 3 months. So 1st month, 2nd month, and 3rd month. And then on the 4th month, she paid, so she's not late there. So the answer to this will give you the balance of the loan at this point here, at the end of the 3rd month. So let's go that. So what do we have? Say A is equal to the answer to that. Let's go and find it. So we say 225,000 into 1 plus 0.09 over 12 raise 3. So we get that the balance is what? Is 230,000. 230,000. 156 cents. So at the end of the third month, here, at this point here, at this point at the end of the third month, the balance on the loan less is owing 230,000. 156 cents. This is how much our friend Lacey owes at the end of the third month. She's owing that much. So which means the balance on the loan at the end of the third month is this one here. Fine. Got that. What were they asking us in the first place? So they were asking, how many payments will Lacey make to settle the loan? Which means, how long will it take her? How many payments she will have to make to settle this loan? Right? No problem. Which is, the present value of the loan is equal to x into 1 minus 1 plus I raised negative n, all divided by I. Right? The present value of the loan, which is the balance of the loan, is 230,000. 156 rands is equal to, how much is she paying on the loan? She's paying 5,500. Right? Into 1 minus 1 plus 0.09 over 12 raised negative what? And which is those are the number of payments, all divided by I, which is what is your I? Your I is that 0.09 over 12. So what you're looking for n, this thing up here, n. Now trying to find n. So how do you get to n? Cross multiply this times that. So we have 230,000, 156 rand times that 9%, 0.09 divided by 12 is equal to 5,500 into 1 minus 1 plus 0.09. 1 plus 0.09 over 12 raised negative n. Right? Then divide by 5,500. Divide by 5,500. This and that go away. So this side, we're left with 1 minus 1 plus 0.09 over 12, all raised negative n. All raised negative n. So let's find the answer to that. Find answer to that. So 230,000 times 0.09 over 12 divided by 5,500. So what do we get? We get that the answer to this is 0.318. This is the answer. Transpose the 1 to the side. So we have 0.3138 minus 1 is equal to negative 1 plus 0.09 over 12 raised negative n. So find the answer to this. Get that it's negative 0.6862, right? It's equal to negative 1 plus 0.09 over 12 raised negative n. Then divide by negative 1 both sides to be positive. Right? No problem. So, want to solve for that. If you want to take this down, you must introduce the logs, right? Take the log of this. Just say log of 0.682 is equal to log whatever this thing is. Log 1 plus 0.09 over 12 raised negative n. Raised negative n. So what does that do? This log, take this negative n and put it in front there. So what you will have a log of 0.06862 is equal to negative n, which is this n of yours, going to in front of what? Of log 1 plus 0.09 over 12. Then you want n, so you divide this log both sides. Log, in fact, you want n, so divide by negative log of this, so that this negative cancels this one. Log 1 plus 0.09 over 12 divided by negative log 1 plus 0.09 over 12. So this and that go away, this and that go away. You're left with n this time, right? Find the answer to that. Say the log of that, log of 0.062 over the log of the negative log of 1 plus 0.09 over 12. You get that your answer n is equal to 50.39. The number of payments is 50.39, right? So you can see that you have full 50 and 0.39. What that tells you is that this person will make 50 full payments of 5,500, and something smaller than 5, that's 5,500. So there will be 50 full payments of 5,500, which is the full amount that she was paying monthly, and a small bit of it. That's why it did not go up to 51, to full 51. This is less than that 5,500. So in total, our friend Lisa, or who is it? Our friend Lacey will make a total of 50 plus 1 payment. So our friend will make 51 payments in total. Done. So we're done with this question. And I hope it does make sense to you as it does to me. Thank you for watching.